Let us finish the proof of the remaining part of the theorem by Muller. We stopped at the point where we are proving the claim where the social choice function f satisfies strategy proofness onto anonymity. Then the social choice outcome must be the same as the median of this agent picks and the phantom picks. So the case one that we have considered in the last module is when the median is a phantom pick. And then we have proved that the social choice outcome should match that phantom pick. Now let us consider the case 2 where A is an agent pick, and in this case we are going to consider only two players. We will show it for two players, and the general case essentially repeats this argument for multiple players, and we will not prove it. So first let us prove this small claim. If we have two players and let's say P and P prime such that their picks are the same, the agent picks are the same. So this should be interpreted as player I has the same pick in P and P prime, and this holds for all the players even though the picks for different players could be different. So this claim then says that the social choice outcome in P should be the same as social choice outcome in P prime. So you can imagine that there could be two preference profiles, P and P prime. Here the topmost alternative is A, B, C and so on for different players. What is happening in the P prime is the picks are remaining the same. The other alternatives may change depending on keeping the single pickness of these preferences, but the picks are unchanged. Then if you have picked, let's say f of P here, that must be the same as f of P prime. So that is all that this theorem is saying. Without loss of generality, you can just look at the picks. If the picks are not changing, the outcome should not change either. So let us prove it. So let's assume that there are only two players. For player 1 the pick is A, and for player 2 the pick is B in both these profiles. In FP the outcome is X, and let's say so when player 1 is changing its preference from P1 to P1 prime and the other player's preference remaining the same, the outcome potentially changes to Y. Now since F is a strategy proof, what we can immediately observe is that X should be at least as much preferred as Y, right? Otherwise player 1 will manipulate from P1 to P1 prime. And the same thing is true for Y. In P1 prime, Y is more preferred than X, right? Now we notice that the picks of P1 and P1 prime are the same. So there could be the following possibilities. So X and Y can be on the same side of the pick. If that is the case, then they must be the same, as this domain is single pick. So if so we know that P1 its peak P1's peak and P1's peak in the profile P prime, they are both the same. So if X and Y are on the same side, they must be the same. Otherwise you cannot have X preferred over Y in one preference and Y preferred over X in the other preference, right? So they must be the same. The only other possibility is when X and Y are falling on two different sides. Then you can have both X more preferred than Y and Y more preferred than X. Now we are going to show that this particular thing is impossible. So why is that impossible? So let us consider the case where this A is the player 1's agent 1's peak, and X is on the left of it and Y is on the right of it. This is without loss of generality, and let us also assume that A is less than B. All the other cases can be appropriately adjusted according to this. Now we know that this the social choice function is a strategy proof and onto, which means that it is also Pareto efficient, and we have shown in a previous claim that the social choice function for Pareto efficiency must live within these two peaks. So player 1 has peak A, player 2 has peak B, and social choice outcome should lie between that interval in order to become Pareto efficient. But now what we have, what we see that the social choice outcome is X, because that is what we have assumed. We have assumed that the social choice outcome here is X, which is lying outside it, because X is smaller than 1. You can repeat this argument. So this is a contradiction. So we see that that is going to be falling outside this interval, and that is a contradiction, because then it does not become Pareto efficient anymore. So you can now repeat the same argument when you do the transition from p1 prime to p1 prime comma p2 to p1 prime comma p2 prime, and there also you repeat this argument to come at a similar contradiction, and then what we have assumed is not true. So essentially this particular implication that x and y fall on two different sides of the peak is not possible, and hence the only possibility is that x and y must be the same. So we will have we show that from p to p1 prime p2 to p1 prime p2 prime, in all these preference profiles the outcome remains the same, x. So that proves this small claim here. Now we are in this state where we have this preference profile p1 comma p2, and the peak for player 1 is A and peak for player 2 is B, and let's say y1. So there is only one phantom peak, which is y1. Now by assumption, in this case, in case 2, the median of A, B and y1 is an agent peak. So without loss of generality, we can assume that the median of these three peaks is A. Now what we actually want to show is that the social choice outcome should also be A, but let's, for contradiction, assume that if P is C, which is not equal to A. Now what we know from Pareto efficiency is that the C, the social choice outcome, must lie within A and B. Those are the agent peaks, and we have shown a result which says that the Pareto efficiency ensures that the social choice outcome must be among these two peaks, within the interval of these two peaks. Now because A is the median, there are only two possibilities: either B is less than A less than y1, or y1 is less than A less than B. In both these cases, the median turns out to be A. So let us consider each of these cases one by one. Case 2.1, where B is less than A less than y1. Now by Pareto efficiency, we know that C is less than A, because C has to lie between A and B. Now we are going to construct a P1 prime, a preference profile for player 1. And we are going to construct it in the following way. We are keeping the peak of this preference to be the same as P1. So P1 has this peak P11, and this newly constructed preference profile also has the same peak. So let's say P11 is here, so P1 prime, that is P1 prime 1, that is also at the same place. And now we are going to set the preferences between y1 and c, and we are going to make sure that y1 is more preferred under this p1 prime than c. And why is that possible to do even in this single peak preference? Because the single peak preferences allows us to pick any ordering for the alternatives which are on two different sides of the peak. So here we see that C by Pareto efficiency is on the left hand side of A, which is the peak here, and y1 under this condition is on the right hand side of A. So y1 is somewhere here and C is somewhere here, so we can actually assign any ordering. So this is always possible to construct in this order. Alright, so that is how our preference profile P1 prime is. Now by this earlier claim, so what we have done in these two preferences, so in P and in P1 prime and P2, the peak for player 2 remains the same, and we have, by construction, we have retained the same peak for player 1 as well. So because of the previous claim that we have just proved, the outcome of f of p is c in the first case, so therefore it should continue to retain the same social choice outcome. Now let us consider the following profile where you have player 1 has the peak at the rightmost position. So remember this notation, you have p11, which means the peak is on the rightmost side, and for player 2 the preference is the same as before. Now what we observe is that for player 2 the peak is at b, which is less than or equal to y1. That is the case here. So b is less than on the left of y1, and because this is the rightmost position, so of course the topmost alternative must be on the right hand side or be equal to y1. So therefore the median of these three things, b, y1 and p11, is y1, which is a phantom peak. So therefore we can actually apply case 1 in this context and conclude the fact that the social choice outcome under this profile is actually y1. That is because of the previous claim. Now what we have constructed is that y1 is more preferred in p1 prime than c, yet the outcome here is actually c. So if player 1 manipulates from p1 prime to p11, that is the rightmost peak, where it gets y1, then this player is going to be better off. And that is a contradiction to the fact that f is a strategy proof. So what we have assumed is cannot be true. So we have assumed the fact that the fp is actually equal to c, which is not equal to a. That cannot be true under this condition. The other case is that y1 is less than a less than b, and of course Pareto efficiency requires that it must lie between a and b, so therefore c must be on the right hand side of a. So the construction is again very similar. We are going to keep the peak of player 1 to be the same and y1 p1c. So this construction is possible because c and y1 are on two different sides of a, and by the claim p1 prime, because the peaks are not changing, so that will also be equal to c. And now we are going to consider a different profile where p10, that's the leftmost peak, the peak at the leftmost position, and for player 2 the preference remains the same. For that this condition holds, and the median peak, so median is actually y1, which is a phantom peak, and therefore the outcome, so by case 1 we can conclude that the outcome will be y1. Now this is more preferred under p1 prime than c, and hence in a very similar way it is manipulable by agent 1. So in both these cases we have shown that it actually leads to a contradiction. So therefore the choice that we have made, f of p to be equal to c, this cannot be correct. It must be equal to a, and that shows that proves this case 2, when a is an agent peak and there are only two players, the social choice outcome must be equal to that alternative a. So this is the proof for two agents for case 2. For the generalization, it just repeats this argument for more players, and for the complete details please see this paper by Muller, which is titled On Strategy Proofness and Single Peakedness.